Hey guys, welcome to another lecture from Introductory Statistics. We have been working on probability distributions. Today we will work on a very important concept associated to any probability distribution, any random variable, and that's the concept of expected value. Expected value or mean for any random variable x. In fact, I'm pretty sure that most of you know that whenever we are calculating expected value, we just use one simple formula. What do? We sum up the value multiplied by its probability. But why do we do that? Let's try to understand this concept. Consider a university having 15,000 students, and let's say x, the random variable, is the number of courses for which a randomly selected student is registered. So, you have a choice of registering for a certain number of courses. So, if we pick any random person, any random student, how many courses is this person uh, registering for? So, X is that number. And let's say it follows the following PMF. The following PMF. So maximum number of subjects you can register for is 7 and the minimum is 1. So 1, 2, 3, 4, 5, 6, 7 is the value that X can take, the number of courses that you can register. And it's coming out in terms of probability. There's 0.01 probability associated to 1, 0.03 associated to 2, 0.13 associated to 3, 0.25 to 4, 0.39 to 5, 0.17 to 6, 0.02 to 7. What does it exactly mean? See, it basically means that out of 15,000 students, some students are registering for one course, some for two, some for three, and so on and so forth. It goes till 7. Now, if I have this probability with me, that probability associated to 1, x equal to 1 is 0.01. That basically means the number of students who are registering for just one subject as a proportion of 15,000 is equal to 0.01, right? That's what is probability. So therefore, we can find out the number registered, the number of students who are registering for one subject, for two courses, for three courses till 7. If we have this probability given, we can do that. So number, for example, as we said, 0.01 is associated to 1. So number registered, how many students are registered for just one? Well, it would be 0.01 multiplied by 15,000. So that would be 150. You can figure out how many students are registering for two courses. You have x upon 15,000. This time is 0.03. So what does it tell you about x? It tells me that 0.03 into 15,000. So that gives me 3 into 150, that is 450 students. So try to relate it to the probability, basically number of students who are registering for certain number of courses, and just associate it in terms of probability, because probability is given to us. Now why is this important? I will talk about it when I'm explaining this entire thing to you. So with this, you get to know that, okay, number of students registered with one subject is 150, with two subjects is 450, with three subjects is 1950, with four subjects is 3750, with five subjects is 5850, with six subjects 2550, with seven subjects 300 students. Okay, and this will give you a total of 15,000 students, and this will give you a total of 1. It's one and the same thing, actually, of course, because that is just the probability. So if you will add it up, it will give you 15,000 upon 15,000. That is 1. Okay. In terms of proportion, if you will see. Now, we have the number of students who are registering for 1, 2, 3, 4, and so on and so forth till 7. The average number of courses per student or the mean value of X, logically speaking, what will that be? I'm not asking you for the formula here. I'm asking you, logically speaking, if you ever have to give me the mean or the average of number of courses per student in this scenario, what will it be? Well, you know that one course is being taken by 150 people. Two courses is being taken by 450 people. Three is being taken by 1950. And similarly, you know that till 7 courses are being taken by 300. Whole thing divided by the total, that is 15,000. You understand? Frequency upon the total frequency. So this is how you calculate mean, right? So in that sense, what is your mean or average? It is, once you calculate, you will get 4.57. Okay. Now, if you just break it, this is your usual mean formula, right? Now, if I want to break it up, if you observe in this scenario, you have 1 into 150 upon 15,000 plus 2 into 450 upon 15,000. Just break up this sum. 7 into 300 upon 15,000. So if you start looking at frequency in terms of this ratio, that is the relative frequency, you will actually end up with the probabilities that we have on, in that table. So you will see that all you have is the average is nothing but 1 into probability of 1 plus 2 into probability of 2 and so on and so forth. 7 into probability of 7. That is the reason why your expected value is the way it is. What you will realize is to compute the population average value of X, you just require two things. You need the possible values of X along with their probabilities. These are the two things you require, and you will, just as in this example, what you can see from the simple formula of calculating mean, you can translate it to in terms of random variable and the probabilities associated. It's nothing but a weighted average. As you can see, more weight has been provided to 3, 4, 5, and 6. So formally speaking, expected value of any random variable X, discrete in this case, okay? Discrete random variable X. Let X be a discrete random variable with set of possible values, say D is the domain, and probability mass function as Px. The expected value or mean of X is denoted by expected value of X, Ex, we write it down. You can also use the symbol mu, but with the random variable X here, and it's nothing but the summation X into its probability over all the values that X can take, okay? So in this case, simple, if we go back to the same example, if you have to calculate your mu will be 1 into P1 plus 2 into P2, so on and so forth, plus 7 into P7. So this turns out to be 1 into 0.01 plus 2 into 0.03 plus so on and so forth till 7 into 0.02. And you will observe that you are again, of course, getting the same value, 4.57. Now, there's something important that you must observe with this example. Why I'm doing it in detail is for you to understand the interpretation of this. If we think of a population consisting of the x values as 1, 2, so on and so forth till 7, then mu, the mean, the average turns out to be 4.57. And here we will take mu as the population mean rather than the mean of x. Also observe your mean mu equals to 4.57 is not equal to the mean of 1, 2, 3, 4, 5, 6, 7, 8, 7 till 7 we are taking. This would be 4. But your mean for this population is not 4 because there is more weightage given to the value 3, 4, 5, 6. Okay. So it is not plain just average of x. Okay. That's very important for you to understand. Another thing which is very important is this interpretation of expected value. You have to be very careful when you're using expected value because, as you can see, 4.57 is not a value that x is actually taking. You understand? X is taking values 1, 2, 3, 4, 5, 6, 7, but not 4.57. But what you're getting as your expected value of x is 4.57. Yes, that will happen. Expected value is not necessarily part of this data set. So this is something which you should be very careful about. 4.57 is the expected value, but that doesn't mean that if you pick any one particular student from this data set, you will get the answer as 4.57 because 4.57 is nobody can choose how many number of courses. 4.57, you can choose one course, two course, three course, four course, five course, six courses, seven courses. But it doesn't make any sense. 4.57. So 4.57 is the expected value, but you do not expect X to take any value like this. Okay. So that is also one thing that you should keep in mind. I hope with this, the concept of expected value and why we have this formula should be very clear in your mind. We will work a little more, get a little deeper into the concept of expected value and variance in the next class. Thank you very much.